Okay, good morning to everyone. So in the last turn, we have started the chapter air and atmosphere, and we have discussed the air, and the moving air is called wind. Characteristics of air, that is air is colorless, odorless, and we have to remember that air is a matter which has a mass and it occupies some spaces. Means where there is an empty space, it will be occupied by the air. Okay, and we have discussed that air is a mixture of gases because air have different air contains different things, just like oxygen, nitrogen, dust particles, inert gases, carbon dioxide, water vapor, and some impurities. Okay, and then we have started the importance and uses of components of air with the first one, nitrogen, and we have discussed that it helps in the protein formation. And second one, we have discussed that it controls the combustion of substance. It controls the rate of combustion, or we can say rate of burning. Okay. Third one, in the manufacture of ammonia by the Haber process. Fourth one, in the manufacture of fertilizer. And fifth, we have to discuss that it is used in the food industry. Okay. Now, how it is used in food industry. Okay, Ashi Dalmia, you want to ask something?
Yes, sir.
What?
Good morning, sir.
Good morning.
Sir, fifth point in the food industry.
So fifth point I'm going to start. It is not discussed yesterday.
Okay, sir.
Okay, so fifth point we have to discuss. It is used in food industry. So you all are familiar with the chips packet and kurkure packet. Okay, so when you buy chips or kurkure packet, you have observed that there is a little bit chips and it is filled with the air. Okay, and you think that the shopkeeper or the manufacturer company fooling us, but it's not like that. The air which is filled in the in the chips packet or kurkure packet is nitrogen. And why nitrogen is filled in the chips packet or any food packaging system or food package? So nitrogen is inert in nature. Inert means it does not react with the foods. So if it does not react, what happened? The food get not spoiled and it lasts for a long time. Suppose if this chips packet, and we are taking two cases. The first one is filled with nitrogen gas, and the second one is filled with the air. Air means air contains nitrogen also, oxygen also, carbon dioxide also. So what happened? This oxygen gets reacted with the food items. This potato chips, or we can say that kurkure. Okay. And if it does react with the food items, what happened? The food gets spoiled, and there is a microbe growth in this packet. So it will get spoiled and it will not fit for eating. So that's why nitrogen is filled in the chips packet. The chips packet you bought from the shops or the kurkure packets or anything. So it is filled with the which gas? Nitrogen gas, because it is inert in nature. Inert means it does not react with the food items in the packet. Now, how it is used in food industry? So have a look here. So it is given in the fifth point that it is used in the food manufacture company, and the containers storing foodstuffs are flushed with nitrogen to remove oxygen before they are sealed. Okay, so suppose these are chips packet. Okay, these are flushed with the nitrogen. How it works? So it works like this. Suppose this chips packet have air in it, so we fill nitrogen gas in all these packets. If nitrogen gas will be filled, it will be flushed. So what happened? The oxygen or the air which is initially in the packet will get outside. Take an example of this. Suppose this is a water bottle, okay, and the water is filled in it, and we want to take out the water. What happened? If we fill pebbles or any stone, what happened? At the point it will come, all the stones will occupied in the water, and the water will take out of this bottle. The water will be outside of this bottle. So in the same way, the nitrogen is flushed in the chips packet. If we fill nitrogen, what happened? The air, or we can say the oxygen, will be outside of this packet, and these packets will be filled with nitrogen, and the food will be safe for us for a long time. So this is the reason that nitrogen is used in the food industry. Now, the second component of air is oxygen. So we all know that oxygen is very essential for us because it helps us in the process of respiration. Okay. So oxygen. So we have to discuss the importance of the oxygen. So the first one is essential for respiration. So respiration is not only about inhaling and exhaling of the air. So respiration also involves the breakdown of food. When we eat food, so what happens in our body? The oxygen help us to break down the food into simpler form. And when these food items break down, what happens? We get energy to do various types of activities, just like studying, reading, playing, okay, walking, doing exercise. So we get energy from the food, and how this food give us energy? By the breakdown of it. How this food break down? By the process of digestion also and respiration also. So the first importance of oxygen is essential for respiration, and second, supports combustion or burning of substance. So without oxygen, burning is not possible. Okay. That's the first thing you have to remember, that essential for respiration. So it is given that oxygen is used by all living organisms to respire, thereby produce energy to live. Because oxygen helps to break down the food into simpler form, and when these food items break down, it provides us energy to do various activities. And carbon dioxide and water vapor are released during this process. So when these food items break down now, so what happened? What extra things release is carbon dioxide and water vapor. So you can learn this reaction when food which we eat react with oxygen. So carbon dioxide, water vapor, and energy. And you can observe when you exhale, so carbon dioxide is also released, and when you exhale in the front of mirror, you can see the water vapor on the mirror surface. So water vapor also released during the process of respiration. Now second, it supports combustion or burning of substance. So we can perform an activity to show that oxygen helps in burning. So here activity is given on the page number 70, that is activity 2. So what we have to do? We have to take a candle. Okay. And the candle, we have to lit the candle with matchsticks, okay, or any lighter. Then we have to cover it with a glass jar. Now, glass jar. So you will observe after few seconds, the candle will extinguish, means it will off. So why it happens? Because for the few seconds, the oxygen present in this glass jar is consumed or is consumed in the burning process. So after all the oxygen get consumed, so what happens? There is no oxygen, there is no supporter of burning, so the candle will extinguish. So it proves that oxygen helps in, or we can say supports in, burning or combustion. Okay. Now I want to ask one question. There are two cases. Okay. Two candles, the case number first and the case number second. Now we cover with this glass jar, small, and we cover with the big glass jar. In the first case, okay, just put your hands down if you have no doubt. When I told you to raise hand, you just raise your hand. Okay. So in the first case, what happened? The candle get extinguished in 3 seconds. So I want to ask about the second case. How much time it will take to extinguish? The option are 3 seconds, less than 3 seconds, or more than 3 seconds. Okay, 3 seconds, less than 3 seconds, yeah, more than 3 seconds. Okay. Okay. Anyone from 6th A or 6th B? Because I have discussed in 6th C and 6th B. So any student from 6th, yes, 6th B. Aditya Yadav.
Good morning, sir.
Good morning.
Sir, more than 3 seconds, sir, because the jar is filled with more oxygen than the first one.
Okay, you have given the correct answer with the correct explanation. Correct. Okay, good. So in the second case, the candle will extinguish, or it will take more than 3 seconds to extinguish. Why? Because this is a big glass jar and it is filled with more oxygen. So it will take more time to consume all the oxygen. So it will get extinguished or off after or more than 3 seconds. So answer will be more than 3 seconds. Okay. Now you can put your hands down if you don't have any doubt. Okay, so it is all about the activity. Now, the activity number 3. So activity 3, before activity 3, I want to ask you a question. It is just based on the chapter ratio and fraction. Okay, so the percentage of oxygen in the atmosphere is 21%. Okay, for us instant, we are taking just 20%. It will not affect oxygen 20%. Okay, so you have to tell me what part or what fraction of oxygen present in the atmosphere. Okay, Manan Kumar. Yes. Ashi Dalmia.
Yes, sir.
What fraction? You
Sir,
know the
what is the
answer.
question?
If oxygen is present 20% in the atmosphere, what is the fraction uh, of the oxygen present in the atmosphere in the fraction?
Sir, I don't know.
Okay, just mute yourself. Okay, Srishti. Srishti, your answer? Sakshi? Okay, Garima?
Sir, I think 1/5.
Okay, correct. So when we change the fraction, the percentage into fraction, what we do? We divide by 100. So 20 by 100 will be equal to 1 by 5. So 1 by 5 part of oxygen is present in the atmosphere, or we can say air. Now we will discuss the activity 3. This activity 3, we have to show that oxygen is 1 by 5 part in the air or atmosphere. So it is given to show that 1 by 5th part of air helps in burning, and which component helps in burning? That is oxygen. So we have to indirectly show that 1 by 5 part of oxygen is present in air that helps in burning. Okay, Abhika, you have any doubt? You have any doubt? Okay, so what we have to do? First we have to take proclaim dish. which is like this. Okay, and we have to fill it with water. Now, first we have to take a small piece of red phosphorus in a propylene dish and float in on water in a trough. Now cover the dish with a bell jar with a stopper. Okay, now we have to cover it with a bell jar. And here is red phosphorus. Okay, now mark the water level in a bell jar. The part of the bell jar above the water level contains air. Divide this into 5 equal parts. Now this bell jar above the water level, we have to mark it with 5 equal parts. 1, 2, 3, 4, 5. What we have done, initially we have taken a dish like this structure, okay, or we can say ball filled with the water and red phosphorus floating on another thing, another plate, or we can say another trough, and this is red phosphorus, and we covered with a bell jar. Okay, now the part which is above the water level we have marked into 5 equal parts. Okay, okay, Aditya Singh, Aditya Gupta. Then we have to remove this glass jar, and what we have to do, we have to light it or burn the red phosphorus. Okay, very carefully. Then when you burn the red phosphorus, what happened? Red phosphorus after burning, it changes into white fumes. Okay, as you burn, you cover with a bell jar. Okay, now you cover with bell jar. So what happened when you cover? The air is present in this bell jar, and in this air oxygen is also present, which helps in burning. As the oxygen is not consumed, the red phosphorus will keep burning. As the oxygen will consume, all the oxygen will consume, what happened? The red phosphorus stops burning. Okay, so as you cover with the bell jar, what happened? All the oxygen will be consumed in the burning of this red phosphorus, and this red phosphorus after burning will change into white fumes. Okay, so what you observe, that as the white fume will dissolve in water, as the white fume will dissolve in water, what happens? The water level rises. Just take a case. If there is a water in this bottle, and suppose we dissolve something, stone or sand, what happens? The water level will rise up. Water level will rise up. So you will observe that water level rise to 1 by 5 part. This 1 by 5 part. So this water has taken the place of oxygen, okay, which helps in burning. So here it is proved that 1 by 5 part in the air is oxygen, or we can say 1 by 5 part of the air helps in burning. Okay, okay, Ansh Pratap. Okay, so this is all about the activity 3. So we have proved that 1 by 5 part of the air helps in burning, or we can say that 1 by 5 part of the air is oxygen. Yes, what happened? Don't raise your hand unnecessary. Now we have to discuss the third component of the air, which is carbon dioxide. Okay, so for the carbon dioxide, the first one, it is needed for photosynthesis, because we all know that in the process of photosynthesis, what we need, that carbon dioxide water, sunlight. So it is necessary. So the first importance is it is needed in the process of photosynthesis. Okay. And without photosynthesis, what happened? Plants will not prepare their food, and we are directly and indirectly depend upon the plants for our survival. So second one, carbon dioxide is non-supporter of combustion. Non-supporter of combustion. So three things we have discussed: nitrogen, oxygen, and carbon dioxide. Nitrogen controls the rate of combustion. Controls the combustion rate. Oxygen supports combustion. Supports combustion. And the carbon dioxide non-supporter. So carbon dioxide is a non-supporter of combustion. So it is used in fire extinguishers. The red tank, the red cylinder you have seen everywhere, it is used to extinguish the fire. So what is this filled with? Carbon dioxide. Okay. Now, used to make Fiji drinks. Fiji drinks just like Sprite, Coca-Cola. Okay, Fiji means when you open it, it makes a hiss sound. Okay. So carbon dioxide is used to make carbonated drinks and soda water. And why carbon dioxide used in these drinks? Because when you open, it makes a hiss sound, and it also helps to increase, it also helps to keep it fresh and prevent from microbes or microorganisms growth. Okay. So carbon dioxide used in fizzy drinks. Why it is used? To keep it fresh and prevent from microbes or bacteria, microbe growth. The first thing we have discussed about the carbon dioxide is that it's needed for photosynthesis. Second, non-supporter of combustion, and used to make fizzy drinks. Now used as refrigerant. Refrigerant means coolant. Okay, so liquid and solid carbon dioxide are used as refrigerant during the transportation and storage of ice cream and other frozen foods. So I want to ask that solid carbon dioxide, about solid. Okay, Garima. Other
Yes,
name?
sir. Sir, solid carbon dioxide is dry ice.
Okay, so you can note in your book that solid carbon dioxide is dry ice. And carbon dioxide is gaseous, is in gaseous state, and it changes into liquid and solid under certain temperature and pressure. Okay, you can put your hands down. No need to raise your hand, all of you. Now we have to show that air contains carbon dioxide. First, we have in today in the first activity number 2, we have proved that air is necessary for burning. Second one, we have showed that 1/5 part of air helps in burning, and which part will help in burning? Oxygen. Now we have to show that air contains carbon dioxide. So we have to take a fresh lime water in boiling tube. Okay. Now, okay, so here it is given that take some fresh lime water in boiling tube, close with a 2-hole cork. Now we have to close it with 2-hole cork. So you can see in the page number 71, figure 6.5. Now there are 2 delivery tubes as shown in the figure. Suck in air through one delivery tube so that fresh air enters the lime water through the other tube. So what you have to do, you have to suck it from here. Okay, and it contains lime water. When you suck this air, what happened? All the air will go outside, and if the air will go outside, there is another passage from here. What happened? The fresh air enters this tube, and in the fresh air we know that carbon dioxide is present. So what happened? There is a characteristics, or there is a phenomena, we can say, when carbon dioxide passes through lime water. So what happened? It changes color, and it changes into milky white or milky color. Okay, so it is given that after sucking air for some time, the lime water turns milky. So it proves that carbon dioxide is present in the air, or it is a component. Carbon dioxide is a component of air. Now we have to discuss water vapor. Okay, so before starting water vapor, we will start in the next class. So if you have any doubt, you may ask. Okay, so you don't have any doubt. So okay, Ashi,
Yes, sir, I have doubt in carbon dioxide.
what you have doubt?
Sir, second one, non-supporter of
Combustion. Combustion means, you just tell me what is combustion. Hmm?
Yes, sir. Sir, what is?
Combustion. What do you understand by combustion? See, combustion means burning. Suppose when you light a candle, okay, and you pass carbon dioxide, what happens? The candle will extinguish. Non-supporter means it does not support burning. Okay. Combustion means burning.
Yes, sir.
Okay, you can mute yourself. Okay, Kana.
Sir, which chapter?
Chapter 6 is going on.
Sir,
Okay, Sakshi. Sakshi.
Hello.
Yes.
Sir, good morning.
Good morning.
Sir, what is the meaning of frozen food?
Sorry. Just
Sir,
like ice creams.
Yes, sir.
Okay.
Yes, sir.
Okay. So we will continue in the next class. For now, thank you. Bye.